I remain your friend, Edu Ada. Today we'll be considering a topic in science, gravitational field. And under this, we have these two questions. Let's go together. 1. The gravitational field or the gravitational force between two objects of masses 10 raised to power 24 and 10 raised to power 27 is 6.67 newtons. Calculate the distance between them if that g is called the gravitational constant. So it is what we need to solve the problem we have at hand. It is a gravitational constant and it is always given. So here we go. Okay, let's do this. Yeah, so we can easily solve. The formula we use is this: F is the constant, the gravitational constant, times the first mass times the second mass. That gotten? So having gotten that, then relate it to the distance between them. It's always denoted by r squared. R, then the distance is squared. Such that we can now solve the question, because the question is written that the force is 6.67. That will be equal to our gravitational constant is 6.67 times 10 raised to the power minus 11 times the force mass 10 raised to the power 24 times 10 raised to the power 27. Everything divided by what's the distance between them. That's what we are looking for. We're looking for r squared. Then we are looking for r rather. We have r squared here. So r should be equal to 6.67 times 10 raised to the power minus 11 times 10 raised to the power 24 times 10 raised to the power 27. Everything divided by 6.67. So this and this can go. So what we have left will be equal to what? 10 raised to the power minus 11, 10 raised to the power 27. Then by law of indices, 10 raised to the power 27, that is 27 plus 24. Subtract 11 from it, you have 40. So you have everything 10 raised to the power of 40. That's what r squared. So r can be equal to the square root of, or let me rewrite it this way, it's much easier for you to understand this way. So I can say 10 raised to the power 40, everything all raised to the power half, that's the square root, so this cancels this becomes 20. So my r is 10 raised to the power what? 10 raised to the power 20 meters. So that's what we have as the answer to that question. So we are good to go. That is 1.1, 1 times. Doesn't change anything. It's still 10 raised to the power 20 meters. Quickly we move to question 2. Now, if you look at question 2, you will observe some things. The question says two planets of mass m1 and 20 m2. Okay, so that should be 20 m1. There's an error there. It should be that the second mass is 2 times 20 times the first mass. That's what that means. So and at the distance of R and R2 respectively, there should be this here from the sun. Yes, distance of that from the sun. So it now says, please, I may need to clear this distance of this and this from the sun. So the question now says, two planets of mass m1 and 20 m1 are at a distance of r1 and 4r1 respectively from the sun. Determine the ratio of the gravitational force experienced by the planet. Now, we are using the same formula, but here you are relating the two planets to their distance from the sun, relating them individually to working them individually with the mass of the sun, with the sun itself. So that means you have two planets you are dealing with. The first planet, so you have first planet, the force can be equal to what? G, our normal G, gravitational constant, then mass of the sun times mass m1 over r squared, r1 squared, then second planet, now let me call this f1. I'll call that the force between that planet and the sun will be f2, and with the same gravitational constant, the mass of the sun times second mass upon what? Radius from the sun, that will be r2 squared. But don't forget, here we were told that r2 is equal to what? 4r1. Do you see that? 4r1. Then you can now square it. Squared. This one is equal to ordinary r1. Squaring it. Are you seeing that? Now let's go again. This can be equal to G as mass of the sun times m1 over r1 squared, and f2 can be equal to G, okay, mass of the sun, sorry, times mass of the sun times the m2. The m2 is what? The m2 is we're told that it is 20 times m1. That is 20 m1. Do you see that? Then upon this one will become 16 r1 squared. Now taking their ratio means f1 over f2. So f1 over f2, that will be equal to what? G times the mass of the sun times m1 over r1 squared divided by f2, and that will turn to multiplication, so we have 16 r1 squared upon what? G have mass of the sun, mass of the sun, then times what? Times 20 m1. So m1, let me change my, okay, m1 cancel m1, R1 square will cancel R1 square. Gravitational constant gone. Mass of the sun gone. Do you see this? So what do we have left? We have this to be what we're having left. Let me clean this so that you see what I'm doing. So I can say my F1 over my F2 is now 16 upon 20, and that will be 4 here 4, 4 here 5. So it's 4. The force operating on the first planet with respect to the force operating on the second planet, their ratio will be 4 to be 4:5. So there we go, and we are done. Thank you for stopping by.